So my talk is about model-based risk analysis. And for those of you who already have UPDM and UAF on your roadmap, you'll be happy to learn about what we do in the area of standards and tools that use artificial intelligence to take your UAF models and perform NIST-compliant RMF assessment of your systems fully automatically. And for those of you who still do not have UAF on your roadmap, hopefully my presentation would add a little bit more points for you to seriously consider this. So UAF-based risk analysis. So let me start with telling you a little tale, the tale of the three kingdoms. So once upon a time, there were the three kingdoms. And one kingdom called SysA was building this wonderful steel birds. However, these birds could not fly because the powers that were ruling this world entrusted the authority to authorize these birds to fly with the people of the other kingdom called the RMF kingdom. And so they had the magic wand that they need to flicker for the bird to be able to fly. This is called the authorization process. However, well, the flickering of the magic wand is a simple exercise. However, before that, a lot needs to happen in the way of certifying that this bird is really worthy of flying, and especially from the cybersecurity perspective, so that none of the bad things happen to it. And there was a problem because the engineers from the SysA kingdom, well, could not fly their birds to go to that RMF island. And the people in the RMF island need to have some information about the system, what it does, how it does what it does, when it does what it does, and so on. So how is it done in the industry right now? Well, one typical approach to doing risk analysis is to run some kind of a cyber war game. We're talking the cyber context, and you saw in the little in your brochure, I was using the word MBCA, Model-based Cybersecurity Assessment. But for cyber physical systems, it's the boundary between what is cyber and what is not cyber is a very delicate one. So I prefer to use the word MBRA, model-based risk analysis. So cyber war game for risk analysis, that works. So you put the two teams together. The red team, which looks at some kind of descriptions of the system and looks at the ways how the system can be attacked. So these are the cyber experts, the penetration testers, the people who know how to break things. Very scarce talent, by the way, not many of them around. And there's a blue team. So the blue team gets some information from the red team, what attacks are considered viable. And then they organize these attacks and manage them, arrange them into attack trees, and finally, come up with the controls and some understanding of the risks. The outcome of the exercise is a risk assessment report. So all this is an information management exercise, right? Which needs some inputs about what this system is, how it is built. So tool support for this process, not much, especially for the red team. So they mostly do brainstorming, and they rely heavily on their expertise and knowledge about the domain. The blue team usually uses Excel to manage the information, which is a fine tool. So, but this means that our little three-kingdom world needs a better infrastructure. So the better infrastructure, where information about the systems that are being built by the engineers is made available to the people who assess those systems. And crazy thought that they can use some automated tools to run the assessment repeatedly, systematically, and objectively. And so that's what the model-based risk assessment idea is about. So the model-based risk assessment. So here is the restatement of the problem. So we have a client who is building a system and is using a rigorous systems engineering process to go through a number of milestones and phases. And at almost every single phase, risk assessment is important, starting from the very beginning, because based upon the results of our understanding the risks to the system, well, security requirements are generated. This process is guided by the NIST Risk Management Framework, RMF process, and in particular, so when it comes to controls or different policies and requirements and mechanisms that can protect the system. There is a big catalog called NIST 853, and this is the catalog of about 1,000, give and take, 1,000 controls that are mandated by Congress. So, therefore, in addition to the systems engineering process, there is a risk management process which runs alongside and which takes the information about the system, so that dotted line that goes diagonally, right? And then produces the risk assessment report that feeds various milestones. And so I'll give you 3 reasons for using models to try to make this process more repeatable, less subjective, and less costly. The model definitely is something that would close the gap between the system. And by a system, I mean, well, it's a system involves people, policy, procedures, hardware, software. It's a complex entity. While a risk management process is an information management exercise. So we need to have information about the system to start feeding our risk assessment process. So a model is an information element, right? If we get a high fidelity model that describes our system, we can potentially start, maybe writing some software that does the analysis of this model for us. Second reason for using models, well, model may exist when the system does not exist yet, because we are still building the system. So the early phases of our system engineering process, however, already need the input from the risk assessment. So we cannot, bring the aircraft into the lab and start doing penetration testing or start, figuring out how it can be attacked by the bad guys, because there is no airplane yet. Of course, the reality is that it's always the upgrade, and not so many projects start from scratch, but still. So the early phases are very, very critical, and they need risk information and controls. And the model is pretty much the only way to at how the system exists at that point. And the third reason, which brings the UAF to us, right? So a model may have already been developed by the systems engineering. So this is the area of the best practices in systems engineering called model-based systems engineering. And OMG is developing standards in this area. UAF is one, but SysML is another one. So it's using tools to actually define systems by first building models and simulating models. So that exactly fits into those early stages of the development of the systems engineering process. And it's all about models. So when we are thinking about starting our risk management process, well, the model might already be there. So why don't we just take it and start doing something with it? So what can we do with it? Well, so here is the schematics for the model-based risk assessment, MBRA process. So obviously in the center of it, in that dotted line, dotted rectangle called assessment and reporting. So in the center of it, we need a systematic methodology. There's a lot of different risk assessment methodologies around, and my team looked at a good dozen of them, because every country has a risk assessment body, and this body publishes a risk assessment methodology. UK has one, France has one, Canada has one, and NIST has one, and Spain has another one. So very, very interesting documents. And when we looked at these different risk assessment methodologies, well, they are all, you can say, well, they are give and take NIST compliant, because NIST provides a nice framework of what it takes to be a risk assessment methodology. However, they are somewhat different in how much guidance they provide, how much structure they provide for an entity to go through the steps and perform the assessment. And some of them are more structured, other than are less structured. And you look through these things, and some of them have a meta model underneath them. You can always sense it. But others are more vague, saying, well, you can do this, you can do that, use your expertise. So we looked at different methodologies and perfected them in certain ways into something that can run as part of this model-based risk assessment. So if a machine-readable description of the system is available from the client as a model, so then the first thing to enable automation is automated import into some kind of a normalized description of the, what the system does and the risk facts for the risk assessment. And UAF fits right into that space, actually into both of these spaces, because UAF addresses the right questions. It addresses what the system is, what the system does, when it does, what it does, and also at the right level, at the operational level, which is where the risks mostly are. Now, the attacks are in more detailed levels, and risks and impacts and consequences are at the higher levels, so which is great. And so we used UAF actually both as the pivotal internal representation for running automated risk analysis, and as one of the models that we can bring into this. And so that allows the automation right there in the center that generates the report. So as you probably noticed, a very characteristic kind of a Y-shaped form of data flow there in the middle. From the left side, there are facts about the system, but from the right side, there come the domain knowledge, because we don't want that tooling in here to be specific to, let's say, assessment of aircraft. So what we want is something like that. So we want to separate the mechanics of doing the risk assessment based on the best practices. And the safety world it has very, very structured methods going through design models, very rigorous, like FMECA, which stands for failure mode effect and criticality analysis. And so what we're talking about, this is automated cyber FMECA. So the mechanics. And we want to separate the mechanics from the imports, because we want to take your model and run it through the tool and generate your NIST compliant report with controls and risk assessments and metrics and all that. And we want also the tools to be retargetable different domains, right? So assessing aircraft requires one set of knowledge, but assessing Navy ships requires slightly different knowledge, but the same mechanics, so the same process. So we want it also, so there at the bottom, we want it to separate from any export information. So we want to build internal model of the risk so that you can then give us a template, and we can generate all the reports based on the template. And there is a lot of reporting that comes with the risk assessment. So just another, attempt to show this. To illustrate what I mean by this kind of a Y-shaped, right? So the gears represent the inference engine, let's say, right? So something that takes the system facts from the model. So for example, in UAF, let's say we have an entity item called flight management system data. So it's in the model, it's identified, and so we got that. So it's one of the system facts. And then from the domain knowledge, from the right side, we have certain ontologies that are related to risk assessment. Some top-down ontologies and some specific information about the particular domain, let's say aircraft, right? Some kind of knowledge. What are the bad things that can happen? What is different about the flight management system, right? So the top-down ontologies, what I illustrate there is different categories of harm, right? So one particular example that I'm throwing into here is disclosure. Well, it's one of the security criteria. So it, and it is related to the asset category. So assets are valuable things in the model, right? Well, UAF model does not say, well, this is a valuable thing. It just says, well, here's a thing, here's another thing, and here is exchange between the two performers. We may want to bring UAF and then use the rules to match our asset ontology to the UAF system facts and say, oh, well, the flight management system data is actually an information asset. And then apply the harm taxonomy. Well, we know what bad things may happen to information assets. And from there, we can derive couple risk facts, and one of them would be the fact that the FMS data is actually an information asset, and the other fact is a claim that there's a certain risk involved with the model under assessment, so disclosure of FMS data. And so that's what I mean by the Y-shaped, right? So part of this structured English statement, disclosure of FMS data, right, comes from the left side, it's from the model, and the other part comes from the ontology. And yeah, so risk profile for UAF is, think about the security views for those who know about the security views in UAF. So some augmentations of your base model showing security enclaves, assets, and things like that. So a risk profile for UAF is a further extension where the risk ontologies and risk facts can be also visualized in the context of the model. Now, there's a lot of benefits in actually doing this approach. So if you are interested in more details, you're welcome to go to contact the System Assurance Task Force. We'll be happy to entertain you more, provide details, or go to the demo area. You can see the Blade Risk Manager tool from KDM Analytics, and we'll show you how we take the SAR example and pass it through the model and generate NIST compliant assessment report. So the benefits of doing model-based risk assessment, right? It builds upon the best practices of RMF. So it makes risk management framework more systematic and repeatable, and removes the subjectivity from this. And the idea is that model-based risk assessment is automatable. That's the goal. So structured and repeatable, with a little bit additional effort, you have an expert system that actually goes through the mechanics of the process and builds the model for you. Now, the benefit is here, of course, that computer-based capability can go through many more attacks than a red team would care to do in a much more rigorous way, larger numbers, more systematic, and then crunch the data, again, much more efficiently than the blue team would care to do, right? Resulting in more accurate, more justifiable assessments, which is a good thing. So that allows the feedback to be given to the people who are actually developing the model, right? Because suddenly, with the automated risk assessment, it doesn't cost you anything to run through the certification process. It's free. So you take the model, you load it in the tool provides you the feedback, the risks, the recommends you controls, and you basically see the same dashboard as your certification and assessment person would see 10 months down the road, right? And you can incorporate the feedback from the tool into your model and rerun the process again, which is very good. And also the risk assessment involves a cause and effect analysis, right? So it involves deep end-to-end, following the exchanges, the passes in the model, which goes beyond the capabilities of a normal, UPDM UAF tool. And that provides additional analytics and feedback to the developers of the model. So it's kind of like a static analysis for simulation. Good thing is, so MBRA nicely aligns with the model-based systems engineering process. So it extends the benefit of your model. So building a good high-fidelity model is a big investment. And the more benefits you can get from the fact that you actually did that investment, of course, the more attractive it becomes. So the fact that we can leverage existing UPDM UAF models, bring it into tools, and start doing the NIST compliant assessments is great. So the other thing is repeatable nature of this process is means that you model the system once and then you can do analysis many times. And you need to do that because of the recertification process. Something changes. You get new intelligence information about some new threat activities. And you have, let's say, 20 different systems that were fielded, right? And the typical problem that the authorization official would do is, well, he needs to make some kind of recall, some kind of reassessment of the systems to see if he needs to withdraw the authority to fly, right? Which is a scary, costly, and a very uncomfortable process. Now, with this capability, so you have the models, they are sitting around waiting for you, so you can, run the tool with a little bit different data and get them reassessed, recertify, see what the consequences are. Makes risk assessments objective and the whole process repeatable. So meaning the same, so if, let's say, if you're evaluating different bids for a project, you can apply the same policy to the models and evaluate them objectively and at low cost using the tool and the same policy. And last but not least, so multiple mitigation options. So you can try different combinations of security controls from NIST catalog and otherwise, and plug in the cost and see what is more efficient. So it brings risk assessments way further away from just the checkmark compliance into the real cyber world where it actually means something, and you can understand the real cybersecurity posture of the system. So just to conclude, the chalice. So that's one of the favorite images for consultants. A process, something that we go through in the community, something that starts with brainstorming. Yes, it can be done. There are best practices, but it takes a lot of experts. Somewhat subjective, but we can train the experts. But as the best practices accumulate, as we understand more and more the details of the process, we can get more automation. We can build the meta models. We can invest into making the methodologies more and more structured. And so at some point, the game changes and we say, hey, so there's an expert system and that does the process for us. And well, at the end, it kind of becomes the easy button. We need less and less experts. We need more operators to run the tool, but that's great because we can now focus on creating good policies, and we can deploy the tooling onto many desktops where the tool would execute a policy. So we can use the experts in a much more efficient way, and that's a good thing because of the fact that having a good trained cybersecurity expert is not really a very affordable and or frequent thing. Thank you very much.